Hi everyone, and welcome to our video on making a graph or finding information from a graph of the derivative. Okay, so they say assume that the following graph is of f prime of x. Okay, so we always want to make sure we catch that, not f of x, this is f prime of x that's graphed. And then they're asking what are the critical values? Okay, so what are the critical values? Well, the critical values are where our function f of x has turning points. So let's make that little sketch here. So if we had y equals f of x, we know that's where turning points are. Okay, so it's there and there based on my little quick sketch. But again, this is f of x, not the derivative. Remember, the derivative would tell you that you have a negative slope at those turning points. So f prime of x equals 0 there, and f prime of x equals 0 there. Okay, so what we want to do then on our problem, again, we have the derivative. We want x values where f prime of x is 0. Well, where f prime of x is 0, this is the same as the x-intercepts. Okay, so that's what we really want. So we want right here, 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 and here. So those are our critical values. So x equals -3, -1, 2, and 4. Okay, so notice how we treat the derivative graph different. There we are. That's it. Okay, so remember it's connected to f of x. So I just drew that little sketch to remind ourselves what those critical values are. All right, now number 2. On what intervals is f of x increasing? Okay, so still let's use purple. So still this is our function f of x that I just made up. Over here is where it's increasing. Over here is where it would be increasing as well. Okay, and then what we want to make a connection with is the derivative. Okay, so remember where f of x is increasing, that's where f prime of x is greater than 0. All right, so we want f prime of x being greater than 0 on this problem. Well, again, it's given us a graph. In our graph, that's where we have above the x-axis. Okay, so this in the purple is where our derivative is greater than 0, because these are positive y values over here. Okay, so that's where it's greater than 0. And then over here is where it's greater than 0 as well. Okay, so we've got those two intervals, and we read it using the x values. So from -3 to -1, and then from 4, and we're assuming it's going forever there to the right. I put a little arrow on it too. So 4 to infinity. And remember, the intervals are always using parentheses. Okay, and then one more. Let's do it in the green. Well, again, using my reference graph, where f of x is decreasing, so that in the bolded green, is where the slope would be downward if we drew tangent lines. So that's where our derivative is less than 0. Okay, so we want our derivative to be less than 0. Okay, so where our derivative is less than 0, again, based on this graph, again, our graph is the derivative, not f of x, it's the derivative. So where the derivative is less than 0 is where it would be below the x-axis. Okay, and let's even mark the f prime of x below x-axis. So same deal, let me just mark that there, f prime of x above x-axis. Okay, so that's this in the green. And I'm highlighting. Oop, that one's a little off. That's okay. There we go. Okay, and again, it's always just using intervals. Okay, so it looks like from -infinity to -3. And then we also have from -1 to 2. Now at 2, we do break it. Okay, so because it crossed 0 for a second, so that means it's not below the x-axis there. It's on it. Okay, so that's why we do a separate interval. And then 2 to 4 is the final interval. Okay, and then that's it. There we go. Done. Okay, so notice again the way that we treat f prime of x different than f of x. If you're ever confused though, I mean, I would always bold f prime of x if they give you a graph to make sure we know which one's which. And then we could still use a reference to help us. That's what I did. Okay, so thanks for watching. If you have any questions, please let me know.